Dear student and learner, today we will see HDI, DU, double bond equivalence. These are the same terminology which is used for determine what types of functional group are present, what are the possible structure, and this is known as a hydrogen deficiency index. So let us see where is it useful and what is the importance in that. So here I have written the two questions. What is the hydrogen deficiency index value for the toluene? The option is given the question which was already asked in JPAT 2018, and what is the hydrogen deficiency index of purine. So after completion of our total slides or presentations, we move to the again on the same slide to give the answer. Let us go ahead. So what is HDI? What is DU? What is double bond equivalency? So simply we can say that a cyclic saturated hydrocarbon, the general formula is CnH2n plus 2. So this is a general formula. More than that, hydrogen is not at all possible in any organic compound. इससे ज़्यादा हाइड्रोजन इस ऑर्गेनिक कंपाउंड में हो ही नहीं सकते. Let us go ahead. So what is a hydrogen deficiency index? So we can say we have number of hydrogen molecule removed from the acyclic sigma bonded compound to form any organic compound. So after discussing one of the definition, we move to the other definitions. So number of hydrogen molecule required to make a molecule into a acyclic sigma bonded organic compound. So there are two possibilities. One is hydrogen molecule we are adding. This is the case of this. And another case is hydrogen molecules we are removing. So this is the case of this one case. अगर यहाँ पे पता नहीं चलता तो आगे we will see this example and understand the hydrogen deficiency index. So where it is useful, and I have bifurcated this lecture or a video in two parts. One, calculate a DU from the structure and calculate a DU from the molecular formula. So let us go ahead and see how it is useful and how to calculate. Suppose the case number one, here I have given you an idea or regarding calculate a DU from the structure. So I will take a cyclic propane. Simply I am taking that I have a cyclic propane. A structure would be like this. Let us see. We will see this structure here. So I can say that this is the structure of what? A cyclic propane. So from this structure, it is also possible that we remove this 2 hydrogen. So from here, by removing a H2 molecule, क्या हमें मिलेगा? We get this is CH, H, H, C, H, H and H. After removing the, one molecule of hydrogen and 2 atom of the hydrogen molecule, hydrogen atom, we are getting one double bond. So we can say the DU of this compound is 1. Let us go ahead and see here one more example. This is also possible that we can remove this 2 hydrogen. After removing this 2 hydrogen atom or hydrogen molecule, what the structure we are getting? We are getting a structure is like this. So this is our possible already structure is there. After removing this hydrogen molecule, we get the structure would be like this. So a DU of this compound is 2. ओके, सो दिस इज वन ऑफ द पॉसिबिलिटी. अगर कोई चाहता है कि सर वी वांट टू रिमूव दिस हाइड्रोजन and this hydrogen, so in that case I suggest him to draw the structure C C C. These are the two hydrogen, these are the two hydrogen. I will give you the numbering so anyone can easily understand. This is A, B and C. So A and C are connected. Here A and B is connecting. So when A and C are connecting, this is A, this is B, this is C. They are connecting here. And after connecting it, we are getting a compound. That compound is known as such a compound, and this is known as a cyclopropane. So here also removal of this two H2 atom or one H2 molecules. So du of this compound is also, I can say it is 1. Very simple. So now a degree of unsaturation is number of hydrogen molecule removed from the compound to make another compound is known as a degree of unsaturation of any organic compound. Suppose from this example we can say that there are removal of this two hydrogen atom, one hydrogen molecule is not as a du1. From here to here, from here to here, if you see here, then there are removal of the two hydrogen molecule. One is this one and another one is this one, and we are getting a du2. So this is a degree of unsaturation. So आमतौर पे हम कह सकते हैं कि du is equal to number of cycle. So there is one cycle. So I can say that number of cycle plus number of pi bond present in any organic compound is known as a degree of unsaturation of this compound. So हमारा concluded equations यही होगा कि du is equal to number of cycle in this organic compound plus number of pi bond. ये हो. Now we will see this example. Let us go ahead. What is the du of the following compounds? It is not written here, but I can say that what is the du of following compounds. Suppose I have one compound is this. Then I have another compound. This compound is like this. I have another compound would be like this. I have another compound, the structure could be like this. Now we have to calculate a degree of unsaturations from the given formula. Take one more example also. We can say that this is one of the compound. Another compound is like this one. Okay, now this formula is given, structural formula is given to us. We have to find out the degree of unsaturation. Degree of unsaturation is equal to number of pi bond plus number of ring. So how many rings are there? The ring are 1. How many pi bonds are there? 0. So what is a du? Du is 1. So how many pi bonds are there? How many rings are there? There are 2 rings. How many pi bonds are there? There are 0. So du is a 2. How many pi bonds are, how many du cycles are there? 0. How many pi bonds are there? So 2. So du is 2. Very simple. Here, how many cycles are there? There are 2 cycles. Plus, how many pi bonds are there? There are 0 pi bond. So we can say du is 2. How many pi bonds cycles are there? There is 1 cycle plus there is 3 pi bond. So I can say that the chances is there is a 4 degree of unsaturations. How many cycles are there? 0 cycle plus how many pi bonds are there? There are 2 pi bonds. So degree of unsaturation is 2. Very simply I can say. So एक तरीका ये है कि हमको स्ट्रक्चर दिए हुए है वहां से हमको du फाइंड करना है. Let us go ahead. Calculate a du from this molecular formula. ये हमारा हो जाएगा केस नंबर 2. This is what? Case number 2. So to calculate a degree of unsaturations from the molecular formula, we required some mathematical formula, and this mathematical formula is nothing but 2c plus 2 minus h minus x plus n divided by 2. This is very simple formula. So 2c, c stand for number of carbon present in your molecular formula. H is number of hydrogen atom present in your molecular formula. X is number of halogen atom present in your molecular formula. N is number of nitrogen atom present in your molecular formula. This is known as this is useful for that calculation of degree of unsaturations. Let us see what are the possibility from this calculations. If we are getting a value 0, we are getting value 1, we are getting value 2, we are getting value 3, we are getting value 4. What is the inference? हम उसके पर से क्या नतीजा निकालेंगे? If this value is 0, then we can say there is no pi bond, there is no cycle. So simply we can say this is acyclic hydrocarbon. Are you getting it? We have seen the formula, number of pi bond plus number of ring. The sum of that is 0. Then there is acyclic hydrocarbon. If du from this formula we are getting is 1, then chances is a 1 double bond or 1 cycle. This is a possibility. We cannot come to the exact judgment, but we can come to the conclusion. These are the possibilities. So let us see. From this formula we are getting a value 2. Then we can say there are 2 cycles, or there are 2 double bond, or there are 1 triple bond, or there is 1 cycle and 1 double bond. Now calculate in all the case according to the formula. Du is equal to number of pi bond plus number of rings, that sum is 2. अगर हमारे पास दी हुई फॉर्मूला के अकॉर्डिंग we are getting this value is 3, then we can say the possibilities here is we come to the conclusion 3 cycle. One possibility is that. Then we can say 2 cycle and 1 double bond. This is possibility. And we can say 1 cycle and 2 double bond, or we can say 3 double bond, or we can say 1 double bond and 1 triple bond. These are the possibilities. For being an aromatic compound or the presence of benzene ring, we should require at least a 4 du. So here I can say right that 4 double bond, then 2 double bond, sorry, 2 triple bond, we can write that 2 triple bond. Is it easy very for us? Then 2 double bond and 1 triple bond. Then we can say 3 cycle and 1 double bond. Then we can say 2 cycle and 2 double bond, or we can say 1 cycle, 1 triple bond, 1 cycle and 1 triple bond, then 1 cycle and 2 double bond, one cycle and 2 double bond. Sorry, not 2 double bond, 3 double bond. Then we have 1 cycle and 2 triple bond, okay, this is not possible, I think. So we come to the conclusion at here only. So 1 cycle and 3 double bond is the final conclusion. So these are the possibilities. ये सभी possibilities है, उससे भी ज़्यादा possibility हो सकती है. So let us go and see this exact example what it is told us. Let us see possibilities of the functional group. Suppose we have one formula is C3H6. Now we will see here also to remember this formula. If we will see that here, for those elements which have only bond formation capacity 1, they are all in a minus, and those who have bond forming capacity is 3, they are plus. And second thing, only we are taking odd bond formation element. We are not taking oxygen because it forms a 2 bond, that is known as an even number of bond, and a degree of unsaturation is mostly applicable to carbon, nitrogen, oxygen and halogen families, because they are they have a fix to make the bond during these chemical reactions. In the period number this, suppose we will take phosphorus and sulfur and silicon, they are a vary in the formation of the bond. So we are not applying here, we are applying for that much only, and we are not considering this also in this formula, is it? So 2C plus 2 minus H minus X plus N, we are applying this formula here. Suppose I have the formula is 2C plus 2 minus H minus X plus N divided by 2, is it? So according to this formula, what we are getting here is 2C means 2 into 3, number of carbon is 3, plus 2 hydrogen is 6. There is no halogen, there is no nitrogen, divided by 2. So we are going to be cancelled out, and after getting 2 by 2, du is 1. Du is 1, there is 2 possibility. One possibility is 1 cycle or 1 double bond, or we can say 1 pi bond, because in 1 double bond there is 1 pi bond, and 1 triple bond there is a 2 pi bond, is it? So what is the possible formula for this compound? So if we say 1 cycle, so the one structure could be like this, and 1 double bond, then possible structure is this one. So this is the useful for us. If this molecular formula is given to calculate what are the possible structure, these two are the possible structure. Let us go here. C3H4, very simple. So here if we will calculate 2C plus 2 minus H minus X plus N divided by 2, then what we are getting here, we are getting that is 2C. Number of carbon is how many? Number of carbon is here are 3. So I can write 2 into 3 plus 2 minus 4. There is no chances of halogen and nitrogen. This is 2. So 6 plus 2 minus 4 divided by 2. So from here we come to the conclusion 6 plus 2, 8 minus 4, 4 divided by 2. the du is 2. If the du is 2, the possibilities of the structure could be, so 2 du, what are the possibility here we have written is, if we see here 2 du means 2 double bond, 2 cycle, 2 double bond, 2 cycle, 2 or 1 triple bond, 1 cycle and 1 double bond. This is the possibilities. So if we see here 2 double bond, so there are 3 carbon, and I can write here not like this but in this way. This is the possibility. 2 cycle, it is next to impossible to make a 2 cycle within a 3 carbon. 1 triple bond, so I could form this way. 1 double bond, 1 cycle, it is possible. Yes, possible hai. Okay, so I will write, I draw again it in this formula, in that way only. Okay, this is the same, but I will write 2 cycle is not possible within the 3 carbon. Let us go ahead and see this, check for this one also. We have a formula C4H6. Let us calculate a du. Du is equal to 2C plus 2 minus H minus X plus N divided by 2. So 2 into 4 plus 2 minus 6, there is nothing more than that. So 8 plus 2 minus 6 divided by 2. So we calculate all and we are getting this value is 2. So du is 2. What are the possibilities for the du2? So for du2, we have possibility is 1 triple bond. Then we have 2 double bond. Then we have 1 double bond, 1 ring, 1 cycle and 1 double bond. Then we have 2 rings or cycle, whatever you want to say. So these are the possibility. Let us try to draw the structure for this one. If we see here, for 4 carbon, this is one possibility. Another one is this possibility. For both this compound, IUPAC name is different. So nothing is more possibility is here more than that for the triple bond. Let us check for double bond. If we see here double bond, so one is this possibility. Another one is this possibilities. Is there anything? No. So there is not more than that. Now we comes to 1 cycle, 1 double bond. So we will take a 4 carbon. This is 1 cycle, 1 double bond. Then we will say take 3 carbon. This is also possible because this is not an carbon. That has also a different du. This is also a difference. Then this is also different, I think. Okay, I don't think so more than that possibility. If you have any, then you can write in my comment. So I will check also it, because this is a possibilities way. So for the 2 rings of 4 elements, it is possible to draw the 2 rings. This is the possibilities for the structure. So कई बार ऐसा भी क्वेश्चन हो सकता है कि दी हुई मोलिकुलर फॉर्मूला के बेसिस पे what are the possible structure with containing the cycle. So this is the possibilities of this question. So ये possible structures है. Let us go and see one more chances of that. So this is the formula C3H6 and O. So if we here see, I have used one heteroatom, and this oxygen has more chances to make this varieties, so I have taken it here. So 2C plus 2 minus H minus X plus N, then divided by 2. So if we will calculate it, then we are getting 2 into 3 plus 2 minus 6 divided by 2, and we are getting a du is 1. Okay, so du is 1, that means there is a possibility of uh, because here we cannot also classify that du 1 means one cycle, then one double bond. If we see it here a one cycle, then what is the possibility? This possibility is there are 3 carbons and this one. Calculate, it has du1 because one cycle is there. Another possibility is this is also. Now case of one double bond, there are 3 carbons, so I can say one possibility is this. Change the positions of alcohol. Another possibility is this one. Again change the positions of alcohol because they all have a different IUPAC name. If you see here, another possibility is this one is also that could also containing a double bond only. This is possibility. This is possibility. These are the possible structure. So यहाँ पे ऐसा भी क्वेश्चन हो सकता है कि दी हुई मोलेक्युलर फॉर्मूला में how many compounds are there which containing this ketone functional group or carbonyl functional group or alcohol functional group or a cyclic compound. These are the possibilities of this question to be asked. अभी तक ऐसा क्वेश्चन आया नहीं है, but from this concept it is a possibility. Let us go ahead. We have this two molecular formula. So from here we can calculate a degree of unsaturations. Then we come to the conclusion that 2C plus 2 minus H minus X plus N divided by 2. Okay, if we see here from that, then we come to the 2 into 4 plus 2 minus 9. ऑक्सीजन लेना नहीं है, नाइट्रोजन is 1 divided by 2. So if we see here 8 plus 2 plus 1 minus 9 divided by 2, it is going to be cancelled out, and 2 is 2 and we are getting a 1. Degree of unsaturation is 1. There are so many possibilities of the functional group. Carbonyl हो सकता है, there is possibility of imine, there is possibility of alcohol, there is possibility of ether. Everything is possible. Let us see one by one. I have try to here a simple 3-4 structure, not all the structure, because if I try to do all the structure, then I need a whole 15 minutes more for that. So the one structure is this is possibility. See, it has also du1, it has alcohol, it has amine also. Let us go ahead. Yes, this has also a du1, it containing carbonyl functional group, it containing NH2 also. Let us see here. Yes, it does not containing any double bond, but it containing one cycle. So du is 1, this is an oxygen, this is an NH2, everything is possible. Now for this molecular formula also we can do the same like this, but from this structure we try to what are the possibilities? Du is 2 because there are 2 pi bond. Let us see here, where is a 1 triple bond, it containing 2 pi bonds, so du is again 2. It containing 1 cycle, 1 pi bond, so du is 2. Okay, so if the molecular formula is given, and they can also ask to calculate the du. Let us go ahead. What is the du of pyrimidine? Suppose a formula for pyrimidine is like this. Okay, for the pyrimidine, if we see here, this molecular formula is, we have to calculate this molecular formula is C4 H4 N 2. Okay, so from this molecular formula, if we want to calculate it, then we can say that du is equal to 2c plus 2 minus h minus x plus n divided by 2. ओके, यहाँ से स्ट्रक्चर के बेसिस पे हम कह सकते हैं कि उसका du कितना होगा 4. हाउ इट इज 3 pi bond plus 1 ring is equal to 4. Okay, so here 2 into 4 plus 2 minus 4 plus 2 nitrogen का divided by 2. So if we see here 8 plus 2 minus 4 plus 2 divided by 2, and it is going to be cancelled out, we are getting a 4. So from this molecular formula also we are getting the 4, and from the structure formula also we are getting the 4. So these are the possibilities of a degree of unsaturation, HDI or DBE. Is a following molecular formula containing the carbonyl group? These are the questions. So carbonyl group is known as this one. Let us check du. Du is equal to 2c plus 2 minus h minus x plus n divided by 2. If we see here, then 2 into 4 plus 2 minus 10. There is not possibility of oxygen. So if we see here 8 plus 2 minus 10 divided by 2, these are going to be cancelled out, is equal to 0. If the du is 0, there is no possibilities of carbonyl group, because in case of carbonyl group at least we required 1 degree of unsaturations or 1 du. Let us go ahead. यहीं पे हम आ गए फिर से कि what is the hydrogen deficiency index value of toluene. So if we know the structure of toluene, the structure of toluene is like this. So from this structure only we can say that degree of unsaturation is 4. Now ये आपके लिए है, what is the hydrogen deficiency index of purine. For that I will not give you the structure of the purine, that also you have to find from anywhere, and to give me the answer in a comment box what is the du, HDI or DBI for the hydrogen deficiency index for purine. So thank you friends to listening a whole video. For getting a more video you should do such a things. And if any topics you want to make, or you required any video, you can write in a comment box please, so we can improve a concept of organic chemistry as well as analytical chemistry. Thank you once again.